going to talk through some of our examples on log equations and application problems. So this first one right here, we find a situation where we have bases that we can't really write as powers of another. Like if I had given you something like 8 to the x equals 16 to the, 2x plus 3, I can write both of these as powers of 2. So this becomes 2 to the third to the x, and this is 2 to the fourth to the 2x plus 3. And so then, now I have the same base in both of these. I can say 2 to the 3x equals 2 to the 8x plus 12, and now the bases are the same. I can set the x when it's equal, and we're back in Algebra 1, and it's not that bad of a problem. This one, however, doesn't work out the same way. So when I see that the bases can't be written as powers of the other, or can't be written as powers of the same thing, there we go, then I'm going to take the log of both sides, and I remember that my exponent can come out front, but don't forget the parentheses. Those parentheses are important because you have to distribute the log of 2 to both of those things. So it happened, same thing over here. I distributed through to get this line right here. Then I notice I have 1, 2, 3, 4 terms, and 2 of them have x's and 2 of them don't. So I'm going to move all the x's to one side and then everything else to the other, which is how I got to here. I factored out the x, getting here, then I divided. This is one version of a calculator ready form. So we could put these together with multiplication, and you could tell me that x is equal to, what would that be, log of 6, because since they're being added, you can multiply them together, and then this becomes 16 times 3 over log of, what is 16 times 3, 48? No, if I'm wrong, I'm sorry. This would also be another calculator ready form. I wouldn't have a strong opinion which one you gave me. But when I go to my calculator, you're also going to often give me the exact, or the approximate answer, so that I can see. We may have had slightly different calculator ready forms, but we end up getting to the same place. So what was this one? It was 3x, so sorry, not 3x. It was log of 3. Do you want to see what I'm, log of 3 plus log, here's the log button, log of 2 divided by 4 log 2, sorry, 4 log 2 plus log of 3. Here's the approximate. Now what I want to show you is the Casio does a cool little thing. We can use the Casio to help us check. So this button right here, right above the on button, is a store button. It lets us store this last answer. See how it says answer and then it's storing that. I can store it as x, or I can hit alpha and then any letter that I want. I'm going to store it as x just because it was easy. And now I can come back to my original problem, which was this 2 to the 4x minus 1, and see if that's the same thing as 3 to the 1 minus x. So if I come in here, it was 2 raised to the 4x minus 1. Yes. I get a value, and then I can say 3 raised to the 1 minus x, and it had better be the same value because these things were equal. And so that is one way for me to check to make sure that I'm right. So that's the cool thing to walk away from with that is that store button right there it is. Okay, the next example that we looked at was this e to the x minus e to the negative x equals 4. So the first thing I did is I turned that into a fraction instead of a negative exponent. And then I didn't really want to deal with e to the x in the denominator, so I multiplied everybody by e to the x, which gave me e to the x squared, because e to the x times e to the x is e to the x squared, minus 1 equals 4e to the x. Well, at this point it got a little weird, so I did what we call a u substitution. I let u equal e to the x, not me, but u. It's still funny to me. Okay, so then that gave me u squared minus 1 equals 4u right here. So this I noticed was quadratic, and life is grand when you get to something quadratic, but it's not going to factor. So sorry, I'm not a nice person. So I moved this over. I did notice because this term was even that I could complete the square pretty easily. So I moved it over, added a box, moved the negative 1 over, made it positive 1. So I end up getting to here, u minus 2 squared equals 5. Then I did the cheer, square root, plus minus. I end up over here, u minus 2 equals plus or minus root 5, u equals 2 plus or minus root 5. Well, and now I haven't solved the question. I haven't finished the problem. They wanted me to solve for x, and I have solved for u. So what I have here is that e to the x is equal to 2 plus or minus root 5. Well, if you think about this, root 5 is going to be between root 4 and root 9. So root 5 is somewhere in between 2 and 3. And so when I subtract that value out, I end up with a negative. So e to the x, if I have e to the x, I can only raise it, I can only get a positive value. There's nothing, if I have e to the x, it can never equal something negative. Okay, so yeah, it doesn't even matter what the base is, but if it's not going to ever be negative. So I'm only concerned about e to the x is equal to 2 plus root 5. Now, once I'm here, if I want to undo this, as soon as I see that e, it makes me think natural log. So I'm going to take the natural log of both sides. Keep in mind, I'm taking the natural log of this whole mess. So if I don't have parentheses, I'm wrong. And now natural log of e to the x is just x. So here is my calculator ready form. When I grab my calculator, I had the natural log, and there's my parentheses, of 2 plus root 5. I'm going to go ahead and store that as x, so I just stored it right away. Here's that value, and then I had, so e, if you remember, here can you see it, there's the natural log button, second natural log button gives me that e to the x, so second e to the x, right, minus e to the negative x. If you remember our original equation, that was equal to 4. And sure enough, we're correct. The next one, on this one, I went ahead and recognized that if I move this to the other side, I could get all of my logs on one side and my other number over here. Well, these two were exactly the same. So there's two of them, or you could think of I'm multiplying those things because I have addition, I'm squishing it together. However you get there, I have this log base 3 of 2x plus 1 squared equals 2. Then I did I heart logs, so 3 to the 2 is equal to this, equal to 2x squared plus 1. I lied, 2x plus 1 squared. So I went ahead and FOILed that out and set it equal to 0 and then factored, and I got two numbers. And here's what I wanted to point out. I can only take, if you remember, your log graph has an asymptote. So just the parent function of for log looks something like this. So the domain is only positive values. So if I get a negative solution here, I need to go back and see if it will work. Actually, whatever solution I get, I need to go back and make sure it works. If I plug in -2, this gives me a -3 right here, and that's no good. Okay, if I plug in +1, I get 3, and that should be fine. And that is fine. So x equals 1 is the only answer to that problem. You always want to check, and it's not always a case of, well, you just throw out the negative, because if I had done something like log of x squared, then I could have plugged in a negative value, squared it, then taken the log of that. Okay, so you always want to go back and double check. The next one looked something like this. I just did I heart logs twice. So it was 2 to the 4 equals log base 3 of x, and then 2 to the 4th is 16. So then I have now I heart logs again. 3 to the 16 is equal to x, and that's some, like, I don't know, 43 million or something. Put it in your calculator, check it out. It's not so terrible. So I'll do the word problems in another video.